Okay, so in this video we're going to be looking at trigonometric identities. Yes, that's the title there. And we're going to write down, in this example, the binomial expansion of a plus b to the power 5. And what that's going to do is going to help us with starting with the cos phi theta plus I sin phi theta equals cos theta plus I sin theta to the power 5. Okay, so that is true using the Morpheus theorem, which we've seen in a previous video. Okay. Our task would be to obtain identities for cos 5 theta and sin 5 theta in terms of powers of cos theta and sin theta. So that's what the task is here. Okay, so the example is actually asking us to start off with the binomial expansion. So a plus b to the power 5. Okay, well we've done the binomial expansion before. We get 5 choose 0, a to the power 5, plus 5 choose 1, a to the power 4 times by b. And we can see the pattern. As the expansion goes on, the first power goes decreasing by 1, and the second term the power increases by 1 each time, so that's now a cubed b squared, plus 5 choose 3, a squared b cubed, plus 5 choose 4, a b to the 4, plus 5 choose 5, b to the power 5. Okay, so that is our binomial expansion there. Okay, and obviously we can tidy that up by working out what each number or coefficient is in front of the algebra. So 5 choose 0 is just 1, so that's just a to the power 5. 5 choose 1 is 5, so that's 5. A to the power 4b. 5 choose 2 is 10, so that's 10. A to the power cubed b squared. 5 choose 3 is also 10, so 10 a squared b cubed. Then 5a b to the power 4 plus 5 choose 5 is 1, so b to the power 5. So that's what the binomial expansion is for a plus b to the power 5. Okay, which we've seen that before. Okay, so that shouldn't be anything too new for us. Okay, well we're going to now start off with the second bit. So we know that if I've got cos 5 theta plus I sin 5 theta, then using the Morpheus theorem but also like in reverse, okay, that is the same as cos theta plus I sin theta to the power 5. And that is very similar to what I had here with a plus b, just the difference is a is now going to be swapped with cos theta, b is going to be swapped with I sin theta. Okay, so that's what I'm going to do here. So I'm going to note to myself that I'm going to swap a for cos theta, and b is going to be I sin theta. That way, when I want to work out what the expansion is to the power 5, I can just substitute it into my binomial 1 up front. Okay, so that's going to give me cos theta to the power 5 plus 5 multiplied by cos theta to the power 4 multiplied by I sin theta. Okay with that step so far? Yep. Plus 10 cos theta cubed multiplied by I sin theta squared. Okay, so I'm just substituting it into my answer for my binomial expansion that I'm starting here. Plus 10 cos theta squared I sin theta cubed. Okay, I'm going to flow under a line here. Plus 5 lots of, well, a times b to the 4, so that's going to be cos theta I sin theta to the power 4 plus b to the power 5, which will be I sin theta to the power 5. Okay, so just substituted cos theta and I sin theta into my answer from above there. Okay, obviously we're going to simplify this But the main thing that happens here is it's the complex number parts, the I, okay, the imaginary number. So there's sort of wee box you might want to just note to yourself here. Well, we know I is the square root of -1. Okay, so we know we're not going to use that as a sort of fact, but that's what we know I is. So if I square that, so I squared would be -1. Okay, so every time I see an I squared, if I get an I squared, I'm going to swap it with a -1. If I then go to what I cubed is, well, I cubed is the same as I squared times I. And if I squared is -1, so that's going to be -1I, which is -I. Okay, the I squared becomes -1 like that. And I to the power 4 would be I squared multiplied by I squared, which would be -1 times -1, which is 1. Okay, so that's what I'm going to get if I get an I to the power 4, -1. The last one I may need, well, the last term would give me an I to the power 5, so I to the power 5 would be I to the power 4 multiplied by an I. So if I to the power 4 is 1, that's just going to be 1 times I, which is I. Okay, so you're going to see I'm not actually going to get anything bigger than an I here. Okay, because a lot of it will either cancel into -1 or +1. Are we okay with that there? Right, okay, so let's start by simplifying this expression now. So that's going to give me cos to the power 5 theta, first term. Then it's going to give me 5 cos theta, sorry, cos to the power 4 theta. I sine theta, well, that's just going to give me I sine theta there. I can't really do anything with that. Then that's going to be 10 cos cube theta multiplied by I sine squared theta. So I'm going to keep it in now, so it's going to be I squared sine squared theta. Okay. Plus 10 cos squared theta I cubed sine cubed theta plus 5 cos theta multiplied by, well, if I do that to the power 4, it's going to be I to the power 4 sine to the power 4 theta plus I to the power 5 sine to the power 5 theta. Okay, so that's me just dealt with my powers from outside the bracket point of view into there. Okay, so now I'm going to use the facts about my I squareds and my I cubes on the right hand side to help me simplify this even more. So cos the 5 theta, that just stays there. I sine theta, that just stays there, so that's going to be plus 5I cos to the power 4 theta sine theta. Okay, so let's put the I at the front. This next one, well, I've got an I squared here, and I squared becomes negative, so that plus will actually not be a plus anymore. That I squared is going to turn into a negative, so that's going to be negative. So it goes away to -1, so 10 cos to the power 3 theta sine squared theta. Okay. And the next one's I cubed, so I cubed becomes a negative I. Okay, so that's going to change that sign to a negative there, so it's going to be -10 cos squared theta I cubed is negative I, so I'm still going to have an I there. So -10I cos squared theta sine cubed theta. Okay. Then I'll come underneath again. And then 5 cos theta I to the power 4 sine 4 theta. Y to the power 4 gives me 1. So that I to the power 4 is going to vanish. It's going to keep it as positive. So plus 5 cos theta sine to the power 4 theta. And the last one, well, I to the power 5 just becomes an I again. So we're going to get plus I sine to the power 5 theta. Okay, so that's me dealt with my powers of I. So what we've got now is we've got either things in terms of I or they don't have an I now. Okay, that's what I've managed to achieve with that step there. Now, the expansion was cos 5 theta plus I sine to the sine 5 theta. Okay, So cos 5 theta was the real part of this complex number. Yeah, this bit up here didn't have an I attached to it. Therefore, everything that doesn't have an I, so in other words, the real part of this, is what cos 5 theta equals. Okay? And everything that's got an I attached to it, because the sine 5 theta was attached to an I, everything that's attached to an I, that's what sine 5 theta equals. So what we're going to do is we're going to equate real and equal parts. Okay? So equating real parts first. So parts that don't have an imaginary number attached to it, so that was the cos 5 theta part. So cos 5 theta equals, and then what we do is just look at the expansion and work out what didn't have a imaginary number attached. So the cos 5 theta at the start, that's going to be the start of our expansion too. The next term did, so we jump over to the minus 10 cos cubed theta sine squared theta. The next one did have an I, so minus 10i there, so we're not going to use that. Then it's going to be plus 5 cos theta sine to the power 4 theta. Okay, so that's what cos 5 theta equals. Cos to the power 5 theta minus 10 cos cubed theta sine squared theta plus 5 cos theta sine to the power 4 theta. Okay, we've done that just by equating real parts there. Okay, so if we do the opposite, so if we do it for imaginary parts, we'll get the next one. So equating imaginary parts. Okay, well, our imaginary part of the complex number was sine 5 theta. And this is going to be equal to everything that did have an imaginary part in it. So the second term did, so the second term was 5i cos to the power 4 theta sine theta. Fourth term did, because it was negative 10i, so it would be minus 10 cos squared theta sine cubed theta. And then the last term was I sine 5 theta, so plus sine 5 theta. Okay, and that's me managed to get an expansion for both cos 5 theta and sine 5 theta there. Okay, any questions on that? Okay.